This is the midpoint and segment bisector video. The midpoint, the midpoint of a segment is a point that divides the segment into two congruent segments. Okay, the midpoint is a point that cuts the segment into two equal pieces. It's perfectly halfway. So looking at this picture over here, B would be the midpoint, and it would cut the segment AC into two congruent pieces, and that's what these little dashes here mean. That means that AB is equal or congruent to BC, that those pieces are exactly the same length. Okay? A line, ray, or segment that intersects a segment at its midpoint is said to bisect the segment, and it is called the segment bisector. Okay, so a midpoint cuts the segment into two equal pieces. Well, so does a segment bisector. So this line here, that L, cuts it into two equal pieces at the midpoint B. B is the midpoint, but line L is considered the segment bisector. So a midpoint and a segment bisector do the same thing. They cut the segment into two equal pieces. But a midpoint is a point, a bisector is a line or a segment. Okay? In the diagram to the left, B is the midpoint of AC, which we've already pretty much talked about, and line L is a segment bisector. Sorry, it's hard to write on here. Of AC again. Okay, so B is the midpoint of AC, and line L is the segment bisector of AC. And they both do the same thing. They both cut AC into two equal pieces. Alright, for example, if Q is the midpoint of PR, find the value of X. So instead of last week we did the segment addition postulate where you took PQ plus QR equals PR. Now we're saying since Q is the midpoint, the midpoint cuts it into two equal pieces. So that means that this piece, PQ, is congruent or equal to this piece, QR. Since they're equal, we can set them equal in an equation and solve for X. We don't have to add them up because we know they're equal to each other. Once you set up your equation, solve like normal, move your smallest variable. So I'm going to subtract 4x from both sides. 7x minus 4x is 3x. 3x minus 16 equals positive 2. Now we have a two-step equation. Add 16 to both sides. We'll get 3x on the left and 18 on the right, and then divide by 3. X is 6. Okay, if it asked you to find what PQ is or QR, either way, you can plug it in. 7 times 6 minus 16. 7 times 6 is 42. 42 minus 16, which would be 26. If PQ is 26, then QR is also 26 because they are equal or congruent. Okay, so last week we added the segments up to give us the entire big segment. This week, if they tell us the midpoint on their segment bisector, then I know it cuts the segment into two congruent pieces. I can set the pieces equal and solve. Alright, if B is the midpoint of AC and AC equals 8x minus 20, find BC. So AC is this entire chunk here. The entire thing is 8x minus 20. So even though they say that B is the midpoint, and that does cut this into two equal pieces, I cannot set 3x minus 1 equal to 8x minus 20. Because the two equal pieces are this little chunk here and this little chunk here. So those two little pieces are not equal to 8x minus 20. Okay? So I can say, since they are equal, I can put a 3x minus 1 here. Those two pieces are equal, so my equation could be 3x minus 1 plus 3x minus 1 equals the entire segment 8x minus 20. I used the fact that the pieces were equal, but then I had to go back and use segment addition like last week. Combine your like terms, so I'll have 6x and negative 2 on the left equals 8x minus 20. Move my smallest variable, so I would move the 6x. And get negative 2 equals 2x minus 20. Two-step equation, so I'd add 20 to both sides and have 18 equals 2x, and then divide by 2. So x equals 9. Okay, it said to find BC. BC was this chunk here, so BC would be 3 times 9 minus 1. 3 times 9 would be what, 27? Minus 1, which would be 26. BC is 26. That means that AB is also 26, which means that AC, this entire bottom, would be 26 plus 26 would be 52. They didn't ask us for all that, but once I have one piece, I can easily find the rest because I know they're congruent. Okay? Alright, if EF bisects CD, so EF here bisects CD, that means it cuts CD into two equal pieces. From C to G is equal or congruent to G to D. CG equals 5x minus 1. GD equals 7x minus 13. EF, the entire blue line, I'm going to label it red now. EF, that entire thing is 6x minus 4. And GF, this little green piece here, is 13. It wants to know what EG is. EG. Alright, this problem is particularly tricky because I don't have enough information in the red segment to solve. Okay? I know that the entire thing is 6x minus 4, and I know one of the pieces is 13, but I have no idea what this other piece is, e.g. It doesn't tell me anything about it. So I don't have enough information in that segment to actually solve what it's asking me to solve for, unfortunately. So this is a two-step type of situation. They want us to use the original information in blue here, the 5x minus 1 equals 7x minus 13. Since that segment is the segment bisector, I can set them equal. If I solve for x here in the blue equation, I can plug that in over here in the red, and that would tell me what the entire red segment is, this entire red segment. It would tell me what this is. If I find that red segment, I can subtract the green 13, and that will give me what I'm actually looking for here in the yellow. Okay, so seems complicated, but I'm going to start with the blue. Okay, so subtract my smallest variable. I'll have -1 equals 2x minus 13. Okay, add 13, it's a two-step equation now. So 2x equals 12, and then divide by 2. So x is 6. Okay, I can use that 6 to plug it in over here like we talked about. So over here I'll have 6 times 6 minus 4. So 36 minus 4 is 32. This entire red chunk here, this whole red piece. Alright, I erased all that so we could see it a little more clearly. Okay, I just found the EF, 6x minus 4, E to F. I found this entire thing, 6x minus 4, is 32. That's what we just solved for. I used CD, I used that other segment, set it equal to each other, solved, and I got x. If I plug 6 in, now I have that entire segment is 32. They told me in the directions that GF was 13, so GF is this piece, and that's 13. So if I take this 32 and I subtract the 13 from it, that would give me 19. That 19 would give me the rest of the piece, which is EG, which is what they wanted. Okay, so the answer is 19. Okay, there was a lot going on here. I had to label a bunch of stuff. I used one segment, solved it because it was a bisector. I solved it, set them equal and solved. Plugged that into the other information I had, then subtracted some more information that I had. So this is definitely a multi-step, more difficult type of problem. Okay, but in geometry sometimes you'll see these questions that have multiple things going on in one picture. Okay, you have to try to label, color code, okay, mark up your picture to make as much sense of it as possible.